Assalamualaikum warahmatullahi wabarakatuh. I will introduce myself. My name is Mr. Hilal. I'm a physics teacher at SMA Unity School in Bekasi City. In this moment, I will try to give the solution regarding the UTBK 2000 examination special for physics subject, the topic about the relativity. Before we start to discuss about the solution of this question, I will try to give the prediction about the probability this material will present at UTBK examination. In my mind, I give the prediction this material will present at the UTBK examination around 30 until 40%. So depend of you how deep to learn about this material. Okay, let's return to try give the solution about this question. I will read the question. Sebuah benda bermassa diam M0 bergerak dengan kecepatan V sama dengan setengah akar 3C, di mana C adalah cepat rambat cahaya pada ruang hampa. Besar momentum relativistis dari benda tersebut adalah bla 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 bla. Okay, recording the question, we have learned about the formula of the momentum. In classical physics, the formula of the momentum P is equal mass point to V. Okay, P is the momentum of the object, and then M is the mass of the object, and then V is the velocity of the object. Because the question talking about the momentum of relativity, so we just change this formula to the momentum of relativity like this. The momentum of relativity is equal the mass of relativity point to V. Okay, before we analyze about the momentum of relativity, so we must know about the formula of the mass of relativity. The formula of the mass of relativity is equal gamma point to the initial of mass. Okay, we call this as a gamma, or the constanta of relativity. The constanta of relativity has the formula 1 divided by in the root of 1 minus V squared divided by C squared. Okay, that's all the way how to find the momentum of relativity of the object. Okay, before we analyze one by one, so we can start from the gamma. The gamma formula is the 1 divided by in the root of 1 minus V squared per C squared. Okay, recording this formula is very complicated in my mind, so I will try to give the other solution how to find the gamma or the relativity constanta. Okay, we just use the other's way like this. We write again the velocity of the object. Okay, the velocity of the object is in the root of 3 divided by 2 C. Okay, and then we just write a new fractional as a gamma. Gamma is equal blah 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 divided by blah 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 blah. Okay, the root of 3 as a numerator, this one numerator, and then 2 as a denominator. Okay, and then we just convert the velocity to the gamma. The position of the number 2 as denominator, we change the position as a numerator like this 2, and then we try to looking for the value of denominator. We just analyze use these numbers using the Pythagoras formula. Okay, I will sketch the Pythagoras formula with the triangle. Okay, this one, the triangle, and then denominator for the two number as a hypotenuse. This one, and then in the root of 3 as a front side of the triangle, because the angle is this one, and then the root of 3 as at the front side of this triangle, the root of 3. So we try to looking for about the beside side, this one. Okay, using the Pythagoras formula, we will find this number. Okay, I will try to write again. In the root of 2 square minus in the root of 3 square. So we will get the number, the root of 1. The root of 1 is equal 1. So we just use this number as a denominator, this one. That's all. The way how to find the gamma or constanta of relativity. After get the constanta of relativity, so we just insert the value of the gamma to the formula of the mass of relativity like this. Two per 1.2 initial mass. Okay, the conclusion, the mass of relativity is equal to 0.2 initial mass. Okay, after find the value of the mass of relativity, we just insert again the value of the mass relativity to the momentum of relativity like this. 2.2 initial mass, and then 0.2 the velocity of the object in the root of 3 per 2.2 c. Okay, we can scrap the numerator 2 and then the denominator. Okay, this one. Okay, so we will get the final solution. In the root of 3, 0.2 initial mass, 0.2 c. Okay, so we can call the solution of this question. The momentum of relativity of the object is in the root of 3.2 initial mass, 0.2 c. Okay, let's we looking for the answer regarding the option of this question. Okay, the solution is D, this one. Okay, that's all guys, the solution of this question. The answer is D. Okay, enough I think regarding the explanation or solution about this question. Okay, I will try to give the solution for the other question of the UTBK examination for physics in the next moment. Okay, assalamualaikum warahmatullahi wabarakatuh. See you.